Hello everyone, I am Niharika Vargane and I welcome you all to my channel. So today we are going to learn about analog transmission and analog to analog modulation. So what is analog transmission? Analog transmission is a transmission method of conveying voice, data, image, signal or video information using a continuous signal which varies in amplitude, phase or some other property in proportion to that of a variable. Analog to analog modulation. Analog to analog conversion or modulation is the representation of analog information by an analog signal. It is a process by virtue of which a characteristic of carrier wave is varied according to the instantaneous amplitude of the modulating signal. This modulation is generally needed when a bandpass channel is required. This figure shows the concept of analog to analog conversion. Analog to analog modulation can be done in three types. First, amplitude modulation. Second, frequency modulation. Third, phase modulation. First, amplitude modulation. In amplitude modulation, the carrier signal is modulated so that its amplitude varies with the changing amplitude of the modulating signal. The frequency and phase remains the same, only the amplitude changes to follow variations in the information. Amplitude modulation bandwidth. The modulation creates a bandwidth that is twice the bandwidth of the modulating signal and covers the range centered on the carrier frequency. This figure shows the concept of amplitude modulation. Amplitude modulation is normally implemented by using a simple multiplier because the amplitude of the carrier signal needs to be changed according to the amplitude of the modulating signal. Second, frequency modulation. In frequency modulation, the frequency of carrier signal is modulated to follow the changing voltage level of the modulating signal. The peak amplitude and the phase of carrier signal remains constant, but as the amplitude of the information signal changes, the frequency of carrier signal changes correspondingly. Frequency modulation bandwidth. The bandwidth of a frequency modulated signal varies with both deviation and modulating frequency. The total bandwidth required for frequency modulation can be determined from bandwidth of audio signals. This figure shows the concept of frequency modulation. Frequency modulation is normally implemented by using a voltage controlled oscillator as with FSK. The frequency of the oscillator changes according to the input voltage, which is the amplitude of the modulating signal. Third, phase modulation. In phase modulation, the phase of carrier signal is modulated to follow the changing voltage level of the modulating signal. The peak amplitude and frequency of the carrier signal remains constant, but as the amplitude of the information signal changes, the phase of carrier signal changes correspondingly. Phase modulation bandwidth. For small amplitude signals, PM is similar to AM and exhibits its unfortunate doubling of baseband bandwidth and poor efficiency. For a single large sinusoidal signal, PM is similar to FM. This figure shows the concept of phase modulation. Phase modulation is practically similar to frequency modulation, but in phase modulation, frequency of the carrier signal is not increased. It is normally implemented by using a voltage-controlled oscillator along with a derivative. The frequency of the oscillator changes according to the derivative of the input voltage, which is the amplitude of the modulating signal. This figure shows the comparison between amplitude modulation, frequency modulation, and phase modulation. I hope you all liked this video. Thank you.